Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
The iconic image of the internet is that of a billion computers that encircle a planetary-sized globe, the Earth. From the perspective of an alien inside a spacecraft that is orbiting around the planet Earth and orbiting a few million miles away from the Earth, the atmosphere of the Earth is only as thin as the skin of an apple, and the Earth is the size of an apple. And the internet will seem like a planetary-sized electronic cloth that enshrouds the Earth with computations and communications. My visualization of the planetary-sized internet that I theorized in the 1970s was comprised of 65,536 commodity processors that were identical to each other and that were equal distances afar and apart, or that comprised of as many tiny identical computers. I visualized my 65,536 commodity processors as simultaneously computing to solve 65,536 initial boundary value problems of calculus that each arose from extreme scale computational physics. I visualized those 65,536 commodity processors as synchronously communicating the answers at the new time step and the new interior boundary conditions of the as many initial boundary value problems of computational physics. I visualized those 65,536 commodity processors as equidistantly separated from each other or separated by an area of 3,000 square miles afar and apart. I experimentally discovered how to harness the slowest 65,536 processors and harness them in parallel and harness them to compute faster than the fastest vector processing supercomputer ever built. I did the unimaginable and visualized an ensemble of 2 raised to power 64 power processors as the building blocks of a new supercomputer, and I visualized them as around the surface of a globe in a 64th dimensional hyperspace. The analog in the 16th dimension was my metaphorical image of my small copy of the internet that encircles the Earth. That small copy of the internet was what I theorized and programmed to record unrecorded supercomputer speeds. It made the news headlines in 1989 that an African supercomputer wizard in the United States had won top prize in computing and won the award for recording previously unrecorded speeds in both arithmetical computation and email communication. I, Philip Emeagwali, was that African supercomputer scientist that experimentally discovered that the impossible to compute is, in fact, possible to compute. My experimental discovery of the 4th of July of 1989 of how to parallel process or how to compute simultaneously and how to compute at 65,536 commodity processors and how to communicate synchronously and how to communicate across 1,048,576 commodity email wires was the breakout moment of my 15-year-long quest for the parallel processing technology that makes computers faster and makes supercomputers fastest. That experimental discovery was the breakout moment for my invention of how and why to use that new massively parallel processing supercomputer knowledge and use the technology to build a new supercomputer that encircled a globe and encircled it in the manner the internet encircled a globe. That experimental discovery opened the field of parallel processing supercomputing.
Insightful and brilliant lecture.